Imagine a place where reality itself comes to an end. Not where life ends. Not where planets end. But where space and time simply stop existing. It sounds like science fiction. Yet according to modern physics, such a place may exist deep inside every black hole. Most people think black holes are giant cosmic vacuum cleaners that swallow everything nearby. But that's only part of the story. A black hole isn't terrifying because it eats stars. It's terrifying because it pushes the laws of physics beyond their limits. According to Einstein's theory of general relativity, space and time are woven together into a single fabric called spacetime. Every planet, every star, every galaxy, everything you've ever known exists within that fabric. Mass bends spacetime. That bending is what we experience as gravity. Normally, spacetime bends smoothly. But inside a black hole, gravity becomes so overwhelming that the fabric itself may collapse. At the center lies something physicists call a singularity. A place where density becomes infinite. Gravity becomes infinite. And the curvature of spacetime becomes infinite. In physics, infinite is a warning sign. It usually means our equations have reached their breaking point. It's as if mathematics itself is telling us, I can't describe what happens next. Some scientists believe the singularity is where spacetime is literally crushed out of existence. Not stretched. Not warped. Not ripped apart. Erased. If that's true, then a black hole isn't simply a hole in space. It's the edge of reality itself. But here's the biggest mystery. Does spacetime truly end inside a black hole? Or are we simply missing a deeper law of nature? The answer could completely rewrite our understanding of the universe. And it may reveal that black holes are hiding something even stranger than anyone ever imagined. Imagine watching someone fall into a black hole. You wait. And wait. But something impossible happens. They never actually fall in. At least, not from your point of view. This is one of the strangest predictions ever made by Albert Einstein's theory of general relativity. Suppose an astronaut drifts toward a black hole while you watch safely from a great distance. At first, everything seems normal. They wave. They move. They continue falling. But as they get closer to the event horizon, the invisible boundary around the black hole, something incredible begins to happen. Time itself starts slowing down. Not because your eyes are playing tricks on you, but because gravity is literally changing the flow of time. The black hole's immense gravity stretches time so dramatically that every second experienced by the astronaut appears longer to you. Their movements become slower. Their voice grows deeper and more distorted. The light they emit is stretched into longer wavelengths, shifting toward the red end of the spectrum, a phenomenon known as gravitational redshift. As the astronaut gets closer and closer to the event horizon, their signals become weaker. Their image grows dimmer. Their movements nearly stop. Eventually, they seem completely frozen in place. Then, they simply fade away. From your perspective, they never cross the event horizon. They appear trapped there forever. But here's the twist. Ask the astronaut what happened, and you'd hear an entirely different story. For them, time feels perfectly normal. There is no invisible wall. No sudden shock. No dramatic flash of light. They simply continue falling. In fact, they cross the event horizon without even realizing it. To them, nothing special marks the moment they pass the point of no return. Two observers, watching the exact same event, experiencing two completely different realities. And according to Einstein, both are correct. But crossing the event horizon is only the beginning. Because once you're inside, every possible future leads to one destination. The singularity. A place where space, time, and perhaps reality itself come to an end. What happens after that is one of the greatest mysteries in science. If you fell into a black hole, you wouldn't explode. You wouldn't burn. Instead, you would be stretched into something thinner than a strand of spaghetti. Scientists even have a name for it: spaghettification. Imagine drifting toward one of the most powerful objects in the universe. At first, you might not notice anything unusual. The stars still shine. Space still looks calm. But gravity is quietly tightening its grip. Here's why. Gravity becomes stronger the closer you are to a massive object. As you approach a black hole, your feet are slightly closer to it than your head. That tiny difference is enough to create an enormous imbalance. Your feet are pulled downward with far more force than your head. Your body begins to stretch. First, it's almost unnoticeable. Then the stretching becomes violent. Your spine would elongate. Your muscles would tear. Your bones would snap under unimaginable stress. Eventually, even the molecules holding your body together could no longer resist. Atoms themselves would be ripped apart. This immense difference in gravitational pull is called tidal force. Near smaller black holes, these tidal forces become so intense that spaghettification could happen before you even reach the event horizon. Ironically, a supermassive black hole, the kind found at the center of galaxies, might let you cross the event horizon before those forces become fatal. But don't celebrate just yet. Because once you're inside, there is no escape. No turning around. No rescue mission. Every path through spacetime now points toward a single destination: the singularity. A place no one has ever seen. And no one can ever return from. Being torn apart atom by atom sounds terrifying. But astonishingly, many physicists believe that's not the worst thing waiting inside a black hole. The real horror begins when spacetime itself starts to collapse. And that's where our understanding of the universe completely breaks down. Imagine solving an equation, only for the answer to be infinity. Again. And again. That's exactly what happens inside a black hole. Physics has explained the universe with incredible precision. We've predicted planets, discovered galaxies, even detected ripples in spacetime itself. But deep inside a black hole, physics reaches a dead end. According to Einstein's equations, gravity grows stronger and stronger until it becomes infinite. Density becomes infinite. Curvature becomes infinite. Whenever physicists see infinities appear in their equations, it's usually a sign that something is missing. Nature doesn't like infinities. They tell us our mathematical description has broken down. This mysterious point is called the singularity. It's where general relativity can no longer describe reality. But another theory, quantum mechanics, refuses to agree with Einstein. Quantum physics insists that information can never truly disappear. Yet black holes seem to erase everything that falls inside. So which theory is right? Einstein? Or quantum mechanics? The answer could be both. Or neither. Scientists believe the real solution lies in a theory we don't yet possess. A theory called quantum gravity. It would unite the physics of the very large with the physics of the unimaginably small. And it may finally explain what truly happens inside a black hole. Until that theory is discovered, the singularity remains one of science's greatest unanswered questions. A place where mathematics fails, physics stops, and reality itself refuses to explain what comes next. What if every black hole wasn't the end of a universe, but the beginning of another one? For decades, scientists believed anything entering a black hole simply vanished forever. Lost. Destroyed. Gone. But some physicists have proposed something far more astonishing. What if the singularity isn't the end? What if it's a doorway? According to several cosmological models, matter falling into a black hole could collapse so intensely that it creates an entirely new region of expanding spacetime. In other words, a brand new universe. From inside that newborn universe, observers would never know they originated inside a black hole. To them, their universe would simply begin with an enormous expansion. Something remarkably similar to what we call the Big Bang. Now imagine something even more incredible. What if our own universe began exactly that way? What if every galaxy, every star, every planet, every person who has ever lived, exists because another universe gave birth to ours through a black hole? This idea remains highly speculative. There is no direct evidence proving it. But it's one of the most fascinating possibilities in modern cosmology. If this theory is correct, black holes don't destroy spacetime. They recycle it, turning endings into beginnings, deaths into births, and perhaps creating an endless family tree of universes. There is a boundary in the universe, beyond which no message, no light, and no knowledge can ever return. It's called the event horizon. The event horizon is often described as the point of no return. Cross it, and escape becomes impossible. Not because something grabs you, not because there's an invisible wall, but because space-time itself has changed. Outside a black hole, you can choose your future. Walk left, walk right, move forward, turn back. Inside the event horizon, that freedom disappears. The singularity is no longer just a place. It becomes your future. Just as none of us can stop tomorrow from arriving, nothing inside a black hole can stop moving toward the singularity. Even light, the fastest thing in the universe, is carried toward it. That's why black holes appear perfectly black. Not because they absorb light like a sponge, but because space-time itself prevents light from escaping. We've photographed black holes. We've observed stars being torn apart by them. We've detected collisions between them through gravitational waves. And yet, everything beyond the event horizon remains forever hidden from us. It is the ultimate cosmic curtain, one that no telescope can see through. No spacecraft can cross and report back from. No signal can ever escape. Somewhere beyond that invisible boundary, reality may end, or transform into something entirely new. Until we discover the true theory of quantum gravity, the event horizon will remain the greatest barrier to human knowledge. Black holes aren't just monsters hiding in space. They are the universe's greatest unanswered question.